Hello everyone, welcome back. This is Mr. Cobalt, and in this video I'm going to be going over the structure of the atom, what the particles are, and where they are. And so let's get into this. Don't forget to subscribe to my channel, hit that like button, hit the notification bell so you are notified of any other videos I put in my channel, and Um, don't forget to put a comment in the comment section. Let me know what you think, if you have any questions. Okay, let's get into this. Okay, so we have here a table of the atomic particles. So there are three main particles in the atom. You have your electron, you have your proton, and you have your neutron. And so the electron, you need to know the charge and masses of these particles. That is something you need to know, and I'm sure your teacher is going to require you to know in some way. So electrons are going to be negative, and they virtually have no mass. Now, this is not true. Their mass number is 0, right? So there's a mass number that goes with each of these particles. And these mass numbers are measured in AMUs, atomic mass units. So even though the electron has a mass number of 0, that doesn't mean that the electron has no mass. It just means that compared to the proton and neutron, the electron's mass is so much smaller that it's practically 0. So in fact, the size of the electron is about 2,000 times smaller than either the proton or neutron. So the mass number is 0. So 0 AMUs. And where do we find the electron? The electron is in the electron cloud. Remember when I talked about the modern atomic theory? Uh, Today's theory of the atom is the quantum mechanical theory, the quantum mechanical model, where we view the electrons in things called orbitals, and the orbitals are electron clouds. They're statistical probability maps of where of a space in which you would most likely find the electron, like to a 90% probability. So we call those electron clouds. We also call them orbitals. So the electrons are in the orbitals or electron clouds. Then these are outside the nucleus. So that's important to remember. So these are outside the nucleus. The other two particles are in the nucleus. So let's go to the next two particles. So we have protons. Protons are +1 charge. So to remember that, P for proton is P for positive. And electrons are the opposite, so they're negative. So protons are positively charged, and they have a mass number of 1, and they are in the nucleus. Neutrons, as the name suggests, are neutral. They have 0 charge. And like the proton, they have a mass number of 1. So both the proton and the neutron have a mass number of 1, and they are in the nucleus. Both of these are in the nucleus. The electron is not in the nucleus. It's outside the nucleus in the electron cloud. Okay, let's keep going. So let's talk about atomic numbers. Well, we talked about mass number. Mass number is the number of AMUs, or the mass in AMUs. What about atomic numbers? We talked about that before. So we know the nucleus has protons and neutrons and electrons. And we know the electrons are outside the nucleus, and the protons and neutrons are in the nucleus. Okay, so we know that. So, but how many of each? So this is really important. This is what you do. You need to know how to figure out how many of each of these particles are in the atom. So let's look at an element on the periodic table. So if you look at an element on the periodic table, this is what you're likely to see, or something very similar. So here we have lithium. Lithium is the symbol Li. Okay, Li, lithium. And what is this top number? Well, the top number is the atomic number. The atomic number tells you the number of protons. The periodic table is organized according to the number of protons. It wasn't always organized that way. It was used to be organized by atomic mass. And the atomic mass is on the bottom. That's your weighted average, and I'll talk about in a moment. But now the modern atomic periodic table is ordered according to atomic number. And so that's the number, that large number on the top. And what does the atomic number tell you? It is the number of protons. That number there tells you the number of protons. So your periodic table is your cheat sheet. So you're allowed to use your periodic table. I'm sure your teacher will allow you to use a periodic table on tests and quizzes so that you can answer questions. So if your teacher asks you, hey, how many protons, or what's the atomic number, or how many protons does this have? You would look for that number on the periodic table above the symbol. Usually it's above the symbol on your periodic table, and it's always a whole number. Right? You don't have fractions of protons, right? You just have whole number protons. So you're looking for a number that is just a whole number. So that's the atomic number. And the atomic number tells you the number of protons. It will also tell you the number of electrons if and only if we're talking about a neutral atom. Neutral atoms have no charge, so that means that the negative electrons must equal the positive protons to balance the charge. So if the atom is neutral, which is usually what you're assuming, unless you're told otherwise, if you have an ion, right? Remember that ions are atoms with charge, and they can either be negative, and you'll have an anion, or they'll be positive, and you'll have a cation. Okay, not a cation, cation. Okay, so uh, if the element is neutral, if the atom is neutral, which is normally the case, then the positive protons must equal the negative electrons. So the atomic number will also be the number of electrons only in the case that you have a neutral atom. It will not be equal if you have an ion with a charge, okay? So this bottom number I mentioned before is the atomic mass number. This is the weighted average number of the isotopes, naturally occurring isotopes. So different atoms of the same element can have different masses, and depending on how much of that particular isotope we have, we can average those together, and then you get that decimal number on the bottom. So that's an average of the masses of your different lithium atoms, which are called isotopes, if you remember from the last video. Okay, so here you have a decimal number, and if you remember that the mass of the atom is your it's going to be your protons and neutrons. If you remember from the previous table, the protons and neutrons have a mass number of 1, and the electrons have a mass number of 0. So they're not going to really add much to the mass of your atom, so we ignore those. So when you're thinking about the mass of your total atom, that's your atomic mass number. That's going to be only your protons and neutrons, practically speaking. So if the number of protons plus the number of neutrons equals your mass number, or the atomic mass number, you can round that mass number to your next whole number. So if this is rounded to 7, that means that the total number of protons plus the number of neutrons is equal to 7. But we already know from the atomic number here, right? We already know from the atomic number here that you have 3 protons. So if the number of protons and neutrons equals 7, then you just subtract the number of protons, and what you're left with is the number of neutrons. Oops. So that means you can figure out the number of neutrons by subtracting the number of protons, your atomic number, from the rounded value of the atomic mass number, which for this case, lithium is 7. So 7 minus 3 gives you 4. So lithium typically has 4 neutrons in its nucleus. Okay, so we're going back to the atomic number. So the number of protons in the nucleus of each atom of that element is the atomic number. So the atomic number tells you the number of protons. It will also tell you the number of electrons if you have a neutral atom, because the positive protons must equal the positive or the negative electrons. So the charges are balanced. So here is a table. You have the elements. So carbon has an atomic number of 6, and that is represented by the letter Z. Don't ask me why it's letter Z, but that's atomic number. So atomic number is the letter Z, and for carbon, the atomic number is 6. Z is 6. And remember, so the atomic number tells you the number of protons, so the number of protons is 6. The atomic number will identify the element. Only carbon has the atomic number 6, and therefore only carbon has 6 protons. Same with phosphorus. Phosphorus is atomic number 15 on the periodic table, and therefore we know from the atomic number that phosphorus has 15 protons. If you know phosphorus has 15 protons, then you know its atomic number is 15. They go hand in hand. Atomic number and the number of protons are the same, always. Okay. Gold is atomic number 79. It has 79 protons. So changing the protons makes a new element with a new name. So only carbon has 6 protons. You change the number of protons in carbon to something like 7, you no longer have carbon. You have a new atomic number, which is now 7 with 7 protons, and so the element is different. So you go to the periodic table, you look at element 7, and you find that it's now nitrogen. So carbon has become nitrogen by adding 1 proton. So you change the protons, you change the element. So now it's a different element with a different name. So sodium, for example, has 11 protons. You can look up sodium on the periodic table. That is number 11. The atomic number is 11. So you look up 11 on the periodic table and you'll find sodium. If you take away one proton, and now it'll have 10, right? So now this element now has 10 protons. It is no longer sodium. It is now neon. So you look up neon, you'll find Ne on the periodic table for number 10. Okay, so changing protons changes the element. Okay, changing electrons, however, does not change the element. Okay, so which of these following determines the identity of the atom? Okay, here's a little test question. Which of the following determines the identity of the element? A, the number of protons. B, the number of electrons. C, the number of neutrons. D, total number of protons and neutrons. E, total number of protons and electrons. Which one? I'll give you a few minutes, or actually not even that. I'll give you a few seconds. 5, 4, 3, 2, 1, and the answer is number of protons. So if you said A, number of protons, you rock. You got it right. Thanks for paying attention to this video. Okay, mass number. So we talked about mass number in the table. So we said that electrons have 0 mass number, and we said that protons and neutrons have a mass number of 1. The mass number is the number of protons and neutrons in the nucleus of an isotope. So please be careful about this. So you have the atomic mass number, which is that weighted average of isotopes. And that's that decimal number at the bottom of your symbol. It's underneath the symbol of your element, right? So for lithium is like 6.94 or something like that. The mass number is similar and related to the atomic mass number, but the mass number is for a particular isotope. So this is a whole number, right? So when you're talking about a particular atom, a particular isotope of an atom, of an element, you're talking about a particular atom. And atoms have whole numbers of particles. They don't have half particles, they don't have fractional particles, they're whole numbers. So your mass number is going to be a whole number, and it is the number of protons plus the number of neutrons in the nucleus of a particular atom or isotope. So the mass number is equal to the positive protons plus the neutral neutrons. So that number is always going to be a whole number. So what you need to be able to do, and your teacher is going to be expected for you to be able to do this, is to fill out a table where you're given isotopes of an element, and you need to figure out what the missing parts in the table are. Okay. So one of the ways in which you write the name of an isotope is you have the name or symbol. You can have the symbol of the isotope from the periodic table. So instead of having the name oxygen, you could have O, and then you have a dash, and then followed by the mass number. This one is missing the mass number. We're going to have to figure out what that mass number is. But that is how you write the names of your isotopes. It's the name or symbol followed by the dash, and then the mass number. And again, the mass number is the number of protons and neutrons. So let's look at oxygen. So in order to complete the name of this isotope, we need the mass number. And the mass number is the number of protons and neutrons. So they gave us the number of neutrons. Well, if we want to figure out the mass number here, then we need the number of protons and neutrons. Well, how do we figure out the number of protons? Well, you go to your periodic table and you look at the mass number. So the periodic table is your cheat sheet. So if you go to the periodic table, right, you look up oxygen, which is O, and you'll find that the atomic number is 8. So it has 8 protons. So that means you're going to add the protons and neutrons together to get 18. And so your mass number is now 18, right? So we got 8 protons, and then we add the 8 protons to the neutrons, and you get 18. But then with the electrons, the thing you need to remember is that unless this is an ion, remember an ion has charge. And if you have a charge on your atom, that means that the protons, the positive protons, and the negative electrons are not equal, right? So that means there's an unbalance of the number of protons, and number of electrons. So the charge will tell you that, and we'll discuss that in a moment. But here, if there's no charge, and it doesn't look like there's a charge, we're assuming that they're neutral. So that means the number of protons and the number of electrons are going to be equal. So now that we have the number of protons and the number of neutrons, then that means the mass number is going to be 18. And so we're going to have to write 18 over here after the dash. So 18 for the mass number. So this becomes oxygen 18. So that's the name of this isotope. So the oxygen 18 isotope. And so here we have the symbol for oxygen in the periodic table. And you'll notice that the atomic mass is 16.00. Sometimes you'll see 15.9994, right? So it's really close to 16. Just depends on the measurement that they're using. Okay. Or how many sig figs they're keeping. Here we're keeping only 2 decimal places, so they round to 16 for that reason. Okay, so that's oxygen. So let's go ahead and do the other one. Here, we're given the protons and neutrons. So we know the mass number is the number of protons and neutrons together. And so we can just add those together. And so if we add those together, we get 75. So 75 is the mass number. Also, since we know we have 33 protons, and we're assuming this is a neutral atom, so the protons and the number of electrons are equal. So number of protons is 33, so the number of electrons should be 33 too. So also, since we know that the protons is number 33, we know the atomic number is the same as the number of protons. That means the atomic number is 33. So to figure out the name of this element, we can go to number 33 on the periodic table, look up number 33, and we find, oh, it's arsenic. So we know the name, and we now know the mass number as well. So the electrons is the same as the protons, so that's 33. The mass number is the number of protons and neutrons together. So we add 33 and we add 42 and we get 75. So then we have 75 as the mass number. So the name of this isotope is arsenic 75. Excellent. Okay, so for this next one, oops, I jumped ahead. Here we don't know the name of this isotope, but we do have the mass number. They're giving us 31. That's the mass number. So we can just write 31 here for the mass number. Okay, so now that we know the mass number, we know the protons, right? They're giving us the protons. So remember, the protons is the same as the atomic number. If we know the number of protons, then we look up on the periodic table the number of the element, and we can write the name. So we look that up. What is number 15? Number 15 is phosphorus with a P. So capital P is the symbol. So instead of phosphorus 31, we could write P-31. Okay, so instead of oxygen 18, we can write O18 and so on. So now we have the name of our isotope. We know the number of protons. We know the number of the mass number. So how do we figure out the number of neutrons? Well, if we know the mass number is neutrons plus protons, and we've got the number of protons, all we need to do is subtract the number of protons from our mass number, and what we're left with is neutrons. So take 31, subtract 15, and what do we get? We get 16. So 16 would be the answer. But let us not forget that we're assuming neutrality in our phosphorus. So that means the protons and the electrons are equal because the positive and negative are balanced. So zero charge, neutral atom. And so again, so 16 would be our neutrons because again, we're taking the number of protons and we're subtracting that from the mass number, which is the number of protons and electrons, or I'm sorry, protons and neutrons. So if we subtract out the protons, all we're left is neutrons, and that would be 16. So there's our 16. So this is a good practice. So you're going to need to know how to do this because I'm sure your teacher is going to give you an assignment where you're going to have to fill in a table like this. So I hope this is helpful. So make sure you know how to do this. Okay, so changing neutrons. So we said before that changing protons, if you change protons, you're going to change the identity of your element. So changing protons means that you're changing the element, but when you change neutrons, you don't change the element. The identity of the element is the same, but the mass is different, right? So if you're adding protons and neutrons to your atom, remember protons and neutrons, right? No neutrons, both protons and neutrons have a mass number of 1, right? So if you're adding protons and neutrons, to your atom, you're going to make that atom bigger or smaller depending on if you're adding neutrons or subtracting them, right? So this will make a new isotope. And so the definition of an isotope, as we learned in our other video, is that isotopes are atoms of the same element, so they have the same protons, but they differ in their mass. And they differ in mass by the neutrons. So remember, the only thing that's really controlling the mass of an atom is the number of protons and the number of neutrons, right? If you change the number of if you change the number of protons, you change the element, right? And the mass is going to change too, but you're changing the element as well. If you only change the neutrons, then you're changing the mass of the atom, but not its identity. So it stays the same element, but it's different mass, and that's what we call an isotope. Okay, so isotopes, atoms of the same element, therefore having the same protons, but they're having different masses due to the varying or differing numbers of neutrons. Change the numbers, change the neutrons, you change the mass, but not the element. So here's an example of another table. So again, this is something you're going to want to be able to do. Your teacher's probably going to give you some table like this, so you're going to want to be able to figure out uh, what the nucleus is and fill in the blanks, right? So here we're giving 3 different isotopes of hydrogen. So what does that mean? It means that all 3 of these atoms of hydrogen have the same number of protons. So they're all hydrogen, so they're given the exact same name because they're the same element, right? So what's different about them? They differ in the number of neutrons. So for hydrogen 1, you have a mass number of 1, right? So if you only have a mass number of 1 and your mass number is protons plus neutrons, and both of them have a mass unit of 1, right? So that means that you can only have a proton here. So you have 1 proton, and of course if it's neutral you have 1 electron, but you have 0 neutrons. So proton plus 0 neutrons gives you a mass number of 1. So we only have a mass number of 1. Okay? But look at hydrogen 2, the name is deuterium. The hydrogen 1 also has the name protium. So protium is hydrogen 1. Hydrogen 2 has a mass number of 2. That's called deuterium. Deut stands for 2. For you Bible people out there that you've heard of, maybe the Deuterocanonical books. Those are the second canon. So deuterium, deut is for 2. So you have hydrogen 2, and that means a mass number of 2. That means you still have 1 proton for your hydrogen. So what's this extra 1 for? That's because you have a neutron. So the mass number is 2. So you have 1 proton and you have 1 neutron. So you get a mass number of 2. And so again, you get 1 electron because you're balancing the charge. So we're assuming this is not an ion, it's an isotope. Okay, so same for hydrogen 3 that we call tritium. So tri means 3. So we have a mass number of 3 here. So we have 3 particles. Again, since it's hydrogen, it has a proton, 1 proton. Otherwise, it would not be hydrogen. And so therefore, it must have 2 other particles. Those are going to be 2 neutrons. So it has 2 neutrons plus 1 proton, and therefore has a mass number of 3. And so these are all 3 isotopes of your hydrogen. And then we have here, these are pictures of your atoms. And so that's it for this video. Thanks for joining me. I hope you enjoyed it. Please like and share this video, hit the subscribe button, and hit that notification bell. Please put a comment. Thanks for joining me. Have a great day.